Hello, everyone. Hello. Okay. How are you doing? Woo! Woo! Yeah. We have the online people here as well. I would say wave to them, but they don't see you, so I will wave to them. Hey, hello. They will wave to you. Hi. So welcome everyone on the second session at Expedition Do. Today it will not be me who's talking all the time. We have two external people joining us. Well, 4 external people joining us from 2 companies. We have people joining us from CoMate, people joining us from WeAre. The goal of the session today, it's about prototyping. Last week we already talked about assumptions, validation. Making a prototype is one way to validate your business. So they will give you some tips and tricks on how to do that. The good news is that for this session, for next week's session, there's no homework, so nothing to submit. Of course, it's important to keep running your experiments, but it's possible that this is not related to your prototype at all. So that's okay. Nothing else I needed to say. No. That's it. I would say enjoy the session. They will give some introduction. CoMate on hardware, WeAre on software, and I will then say a little bit what if you want to prototype something that is not hardware or software. And then afterwards, there will be some time to talk with them to maybe discuss your case a bit. So just to know what to expect from the session.
Maybe the last rows can sit up front because it's a bit weird.
Yeah, there's still a lot of space here. I don't bite, and I think they don't bite as well.
Ja.
Oh ja, nee, ik denk dat de camera. Ja. Ja, moet ik het?
Ja, is goed.
Daar nu nog gemute. Ik moet even kans een stage gebruiken, want ze is vooral. En dat is dat is een
All right. Good evening. Hi, my name is Mathieu. I'm a project leader at CoMate. And at CoMate, we are engineers and designers who develop products. And not working. Okay. So for today, I have a short introduction in how we do product development, and then a lot of focus on prototyping. So what is a prototype? Why do we prototype? How do we tackle that? When do we apply that? And then also a brief look into our kitchen. What have we already built as prototypes, and how do we tackle specific cases? So like I said, we do engineering and design. A big focus on engineering because we make hardware products. But the design aspect is not only looking nice products, but also a lot of focus on what should a product be and what is really important from a product point of view. So that it's not really only the technical aspect, but really from a product that you want to make a success in the market. How do you tackle that? And if you look at our values, you'll see that from CoMate, we really have that really deeply embedded to make things quick and dirty. Just go out there, make something in cardboard, even in a foam and plastic, simple things just to check certain assumptions that there are, like Jolien was saying. So we really have that deeply into our DNA. And you see later in all the prototypes that we make that we really do that very quickly, very often to go really quick and dirty. Another part, which is also an important value for us when doing product development, is that failure is your friend. May seem a bit strange that failure might be your friend, but any good idea during the process will fail at some point. And the thing is, the earlier it fails, the better it is, because you have not spent a lot of money already. And you also need to fail often, because from that you can learn new things. We see that on the product, on the engineering side, but also really on the concept, on the idea. The sooner you start challenging your idea with certain with your customer, with anybody, you'll see that that your assumption might be wrong and that you need to pivot and change things. So just to say, it's really embedded in our DNA and how we tackle product development. And if you look at really the full development cycle, see that we do a lot of iterations, and the first part, 3 of the 6 cycles, are really focused on questions, on asking the right question on your idea level, but also on the concept, your solution, what are you building, how are you building that, doing feasibility, going out there, making a first prototype to really test if the critical parts are working before you really build a product. So you see that a lot of it is making the right product before you start building the product in the right way. And that's really, I just wanted to emphasize that quick and dirty prototyping, failure, and half of the development cycle is really questioning yourself and your idea and your concept. So a first story is about rats, and it's a focus on what is a prototype. Because if you ask people what is a prototype, people often think about something like this. You'll see this is a product we developed. It's a snowblower, which is fully automated, fully autonomous system, which connects to a snowblower, but also can connect to a lawnmower or other applications. So you would think maybe a first series, the first one you really built is a prototype. We will test it now, how well it works. And fully functional first version, so to speak. Well, we define it in another way, because the very first prototype for us that we built looked like this. It's really just a wooden construction just to test the connection system, because it's an autonomous system. It needs to connect autonomously. If that doesn't work, the whole product is nothing. It stops. So what we did is really make it really lean. The only purpose was the connection system, and just go fast and test if that solution might work. And so if you look at what is the true meaning of a prototype, it's a rat, means it's the riskiest assumption test. The riskiest assumption that you have is the first one you need to test. And how do you test that? It's really by building the absolute minimum that you need to test if that assumption is true. And I think, that's a really important part, and you'll see why it's so important. If you look at the 6 phases again, first one is just the ID. The last one is the verified product. You see that when you have an ID, there's a lot of unknowns, a lot of risks still there. But the good thing is you have not spent any money yet. The more you go deeper and deeper into building an actual prototype, you'll see that the cost to do an iteration, to review your product will get really high. So the earlier you start testing things, the better. And the 3 first phases, going from questioning your ID, questioning your solution, and really building dedicated prototypes, is really the most important one, which we cover as a research topic. Then in the end, you also build prototypes, of course, because before you build up a complete production line, you also need to do that. But at that point, the risks should be very low. Second story is about airplanes and garden hoses. It's more about why do we prototype? Maybe a little first step is what is the number 1 reason that a startup fails? You see that first one is there's no market need. And no market needs doesn't mean that the idea is bad. It could also be that it's just your solution does not fit the requirement of the end customer. And for that reason, maybe a small detail to you, but for the customer, it might be a very important one, that they say, yeah, but this is not convenient to use, or it's not what I expected it to be. And in that way, your product is just not a good fit. So when you build up your product, we always look at it from 3 lenses of what we define as design thinking. From a product level, it's what do people want? Do they value what our solution is? Because that's the most important part. If they say, okay, the solution has an app, is nice connected to something, it might be very sophisticated, very nice, but if people don't want it, there's no value in it. Next is feasibility. It's about technical questions. It's about, is it something we can make? And the third one is viability. Is the price okay to build a business out of it? And these 3 need to match before a feature should make it to your final product. So we tested on the 3 levels. On desirability is the one we start with. If there's no need, there's no point of developing something. If there is a need, we look at how we can develop it. We do the feasibility work that is necessary, and then we check, okay, what would be the price, and does it still make sense as a business? So these are 3 things which are really, really important to take into account for every feature of your product. So that garden goes, the second story, it's just to show that it's not always that easy to do it. We had a customer who wanted, let's say, kind of a car wash system for airplanes. They wanted to clean airplanes. Nowadays, they do it manually. It's not so easy to do that. They run into a big place to reach all the components, and they said, yeah, we want a system that can make it easier. So together with the customer, we determined a certain architecture, a sketch like this. Okay, we will make tubings and a system to clean and so on. And yeah, okay, we agreed this is a good solution. Next thing we did is go out there and test if the solution would work. And really, this is really super important, because here you see with simple things, just a garden hose, a backpack, some sticks, if that solution might work. And we're a professional company, but we do things like this just to make sure we don't make mistakes, because once we start to draw it in a CAD model and start ordering all the parts, you might see, okay, this is just not fitting. Because yeah, there we saw, okay, there are places that are difficult to reach, others are easy to reach. Can we do that with the solution that we have in mind? So there we came up, okay, this solution might work if you have something to stand in and you have kind of a system to guide your cleaning. That would work. So yeah, we will go to something maybe more like this. So a modular system where an operator can move if required. So something like that people can wear and can reach all the places. So next step is then feasibility. We started working on that system to freely operate without too much weight, the whole construction. And once we built this, we again tested if the weight was not too high of the complete construction we would build, because from the model we can just extract, okay, this will have this weight. So we just do a test like this and we see, no, this won't work. This is too complex. So the first iteration was, yeah, we need to reach everything. And then we saw, okay, yeah, this might be a solution. So yeah, then we came up, this won't work. So next step is, okay, let's look at another solution. Here again, might also not work. So you see that we have a lot of iterations before we get to a final product. And most of it did not cost a lot of money. It was just going out there, asking to your end customer, can I try this? Would this work? Let them follow them, see how they do it. And from that extract what is really important for their product. And that can be done on very early prototypes already. Here you can see previous one. This is the final solution that we built. So from that first prototype where we just went out with a backpack and some hoses, we get to this with the necessary flexibility to reach all the places that are needed. And yeah, this just works and is out there and it's used. So if we would have started with the first iteration of the concept, yeah, it looked totally different than what we have built in the end. So this is why we build prototypes in every possible phase, just to make sure that we build the right product and that everything has been covered. So how to prototype? It's in fact very simple. It's about everything that you think you know, that you test to make sure that you really know it. So we first say, let's state everything that we think we know, or that might be critical to the system or what we want to build. And then we start to extract what is really important, map the assumptions, might be something you have seen in a previous session, and then build the RATS test. That is the most critical one to do, and iterate until you get a final solution. So I have an example of really that very early phase where somebody just had a good idea and just wanted to came to us and said, okay, let's build this product. And there we start asking questions. You'll see the example is Australian. It's I think quite known ice cream, not manufacturer, but brand indeed. And they came to us with the idea, we want to build an espresso machine for ice cream. All right, we said this is a really cool idea, very cool. But which problem are we solving here? Because this sounds really nice. It's a very nice tagline, an espresso machine for ice cream, and you start to visualize, and everybody has an idea in his mind. Okay, this might look like that, but what are we solving? And they said, yeah, we don't know. We don't know what we're solving, but we have this idea of the Nespresso machine for ice cream. So what we do then is really look at stating everything that is important, and that starts with the customer. They said, okay, these are ice cream lovers then. If somebody needs a system like that, the problem, yeah, they can't have the best ice cream for 24/7. They need to go out and or they need to use the freezer. And the solution is then we make a desktop device that makes ice cream instantly. And so this is already better than the statement of the Nespresso machine. But then this is a bit tricky slide because it's difficult to read everything, but then we start to extract and ask questions about every part of what they state. So the customer is ice cream lovers. Is this really the best market, or should we go B2B, maybe a hotel or any place that might have needs for something like this? Are they also unwilling or unable to get fresh ice cream? Is this really true? What are the motivations? The other thing is, they are not happy with regular ice cream. That was the assumption of the client. Is that really the case? So here you see, we ask a lot of questions, but also on the product itself, because making cups for ice cream, is that something that people want? Is there another solution? Is there something that might be better? But anyway, if you do this work, you'll see that there are certain assumptions here which have no ground at all, and others are maybe already more evidence-based. And that's the next step that we do. We just look at what is really critical to the success of this product and what has no evidence. And if it's something that you assume that is really, really critical, but there's no evidence, then you know what to test first. And that could be something really technical for which you need to really build a system, like the snowblower. You said, okay, if it cannot connect, then there's no point in building a system. But here it could also be, yeah, maybe there's no market, nobody wants this, or it needs to have the right size to fit in the kitchen, because otherwise people will say, I will not buy something which is too big. So here, prototypes are, if you need to check, is it not too big? You need to make something which has the right size, looks already like a final product, to go out there, test with people, and see if they really want this. So it's always about testing, and it can be with prototypes, but it can also be just with sketches or render, anything, just anything that helps you clarify these assumptions. And that's what we really do all the time. So we really go in every stage of development, we question every part of it, and we really help thinking with our customer, how can we build the best possible product, and which things need to be tested before we go faster. So let's have a look at what we have built already. Some examples. First one is VR gaming. It's a very basic example. It's a motion capture system that they wanted to build. And the difficulty here is that you cannot have really a good absolute positioning system. So if you start running away and running from one wall to the other, at a certain point, the room seems to be smaller than when you started. So for that, you need external devices and so on to calibrate. And what we did is we just used our iPhones, attached it to certain reference points, and just did measurements of how well is that alignment working, just with the motion sensors of a smartphone. And so we didn't build any custom prototype, but we prototyped with what is available. And in that case, we saw, okay, we're very close, but we will need to develop a custom ultra wideband system, one additional system, and that will be it. So from a costing perspective, that's really a very easy solution. So this is a first example. Another one is for shipment of diamonds. Our customer HP in Antwerp wanted to track every step that a diamond has been made through the processing, from really the mining to the store. So they wanted the system to make sure that no steps are not raised. So what they wanted is a box which every time it's opened tracks that it has been opened and has a location information. So critical in this system is that the connection system of the box is really, very performant. And so we built a lot of slots, connection systems, a lot of prototypes just to test, will this be robust enough in the end to check every time you open the box that there's no way of opening the box without noticing. So it's not about really protecting the diamonds, it's just a shipment system. If the box would be broken, it's also clear that something went wrong, but nothing more than that. So here we did a lot of prototyping iterations to come up with which kind of lid would be good. A lot of iterations, and now it's already in the market. It looks like this now, and I think there are 100,000 sold, or is it 10,000? A lot. It's a lot, which are already used now in diamond markets. So here we just made, I think, half a year of iterations to get to a final product, because once you start to work with these kinds of volumes, you have a huge startup cost of your production. Other things are user mockups. Sometimes it just looks like this. It's just foam and cardboard stacked on top of each other just to test, okay, would this work for a patient? The solution that we have in mind, just that simple. Another thing that we often do is just use foam, make something which has the actual size already, just not to be misled by your CAD model or anything that you start building up, because it can look really nice, but once you feel it in your hand, you see, okay, this is not so convenient. So we first start with just foam, and then we go to something which is 3D printed like that. And this is a final product used in production. So there we do the the same steps. Sometimes it even looks like this. It's just to check if all the tubings would fit. It's nothing more than that. It's just we make tubings on the right size, just something easy as this, just to check, okay, will this architecture be feasible in the end? Because tubings are difficult to model. And this is then the final product. So the step between that first iteration that we built just to check if it works to this is it's a huge step. Also breadboarding, just testing out stuff the most easy way. Here it's a steaming machine for a Meal Hero. It's also just an Arduino, just steaming options that we tested. A lot of 3D prints to see, okay, how is the steam behaving, or what would be the best solution here. For Meal Hero, like I said in the beginning, we also made just a mock-up. This does not work. It looks like a final product. It's just to put on the, to question users and to see, okay, would this be something that you want in your kitchen or not? And then the final product looks like this, so it's already quite close, but at least we get confirmation of the markets that this is something that they want. This is the ice cream machine. This is a prototype that already works like a final product. So here we did two things, also the mock-up, but also a first iteration where we didn't look at form factor, just make sure that it works. And this is then the final products of the ice cream machine for making 2 cups of ice cream. And this was also what came out of all the surveys and all the prototyping that we've done, that this would be the best solution. This is then again the snowblower. It's also just, we first did the connection system, then we didn't care about the connection system anymore. The snowblowing part needs to work. So yeah, it's again a subsystem that we built. And then in fact, the actual alpha prototypes, the beta, so things that are not manufactured in a final way, but are already looking like a final product and also works like a final product. So maybe to conclude, it's in every step of development, we question things, we make prototypes in any form factor. And I think if you would ask in which phase is it best to work with maybe an external company, because there's a lot of work that you can do. I think in the concept design phase is where we start building the actual architecture of a system. There, a lot of input can come from you guys, but also a lot of technical expertise from our side to come up with how could this product look like in the end. And this is something where we can definitely help. And then further on development itself, that's what we do every day. But yeah, like I said, every step we can assist. But I think once you get to a lot of enough information from the field, I think it's the moment to talk to a company like us. All right, that's everything from my side for now. So let's catch up after the session, and I leave the floor to VR.
If there are any questions, we will maybe do them afterwards, or are there any questions now, really? Like more generic questions that are not that specific to your products?
Good evening, everybody. Can everybody hear me well? Yes? Okay, perfect. So I'm Guillaume. I'm one of the co-founders of WeAre, and we are kind of the mirror of Comate on the software side. We build innovative products using software. I'm going to very, very shortly introduce WeAre, and then as fast as possible, I'm going to give some more insights about software prototyping. So when do you want to come to a company such as ours? Well, yeah, you just can't do it all by yourself. We can help you with some expertise, of course. Speed is key. I'll go into that a bit deeper later. There is a lot of war for talent. You might find good developers, but it's not that easy. And they're already in our team, so it's perfect. And we have a lot of expertise in guiding companies like yours, and also larger companies. So especially on the guidance part, we can help you as well. So yeah, this is the team, and we like to think that we're not the average software consulting company, that we do it differently than everybody else. So I'm only gonna talk about this here, but read them all, please. So lean and agile is very important for today as well. Try to work on an iterative way and to try and develop your product in a step-by-step guide. But that doesn't say much. I'll go deeper in it later. Good. These are some logos. You might recognize some companies. Some of them were also in the Uganda expedition, etc. Good. Enough about me. Now let's talk about what you can do to make your software product the best possible. Let's start with this slide. I don't know if anybody has any idea what this number could mean in the context of software prototyping. Anybody want to do a wild guess? No, nothing.
A successful project.
Could be, but it's not. It's in the right direction already. Someone else that wants to do a guess? No, okay.
Features that make it to the end product.
It's about features, but it's only from research, only 50% of the features of a software product is actually used by the user. So that means that 50% of the effort you put in your product and the money is just lost. So let's talk about how we can reduce this number to 0, and let's talk about how we can build something that the user actually wants. So yeah, this was actually the connection slides. How can we build better products faster? I'll go into these 3 details, and then I'll try to do a live demo, which is a bit scary, but we'll try it anyway. So one very, very important aspect, and I'm very grateful that Ko made the introduction and they said it already, is the end user. We always, when starting to build a product, put that end user in the center, ask and look what they want to see if my next feature, my next iteration makes any sense. And I think some people might recognize our table of the meeting. Good. The first thing I said was quick. Why should you want to be quick? Anybody a wild do you want to be quick as a startup or in general? Nobody?
To be faster than the competition.
That's also, but I was thinking more in the software prototyping, in the bringing your idea to the market.
Time is money.
Yeah, as well.
Get quick feedback.
Perfect. You're thinking about the users. So you want to get to that user as quickly as possible. Yeah, you're already winning. Thank you. You want to get to that end user as quickly as possible. So you might have a crazy idea, just sketch it out, call your grandma, ring the bell of your neighbors, talk about your idea. It's the first and quickest way to get feedback about your idea. The downside of developing software is that you can't build your software with cardboard. It's a bit difficult, but you can sketch it on paper. You can even sketch it on cardboard if you want to, and you can make it interactive, make it very simple. It's a very easy way to go very quickly to your end user, to test your ideas, to gather feedback and improve. It's the same for hardware, but just apply it on software. Yeah, I'm not going to ask why you want to be cost efficient. I think that speaks a bit for itself. I'm a bit jealous about the graph you guys showed with the risk is very high at the beginning and the cost goes up. It's exactly the same for software. So at the beginning, when your assumptions are not validated yet, it would be a very bad idea to start spending a lot of money on building features you didn't even validate. I think that makes sense, but try to be cost efficient by talking to your users. Again, I'm not repeating myself. Good. Maybe I can ask the question, why would you want to be iterative? Why do you want the process of prototyping to be a step-by-step process? Nobody?
so that you don't have to throw it all away if it's not good.
It's one of the reasons. This. Anybody else wants to give some input?
To be able to launch the most important features quickly.
Yes. Sorry,
What the user asks isn't always what they actually want. There's a difference in what they say because they don't know the correct IT terms.
Yeah, that's true. That's true. They might ask for something and mean something else, but then maybe you should validate your assumptions in another way as well. But that's also a risk. So what we often see is that by iterating, you can keep better track on your objective. It's way easier, and you can validate assumption by assumption. It's a very bad idea to try to validate all your assumption at once. You can do it step by step. You can take small steps in the right direction, which is often way better than taking one very huge leap in the wrong direction, of course. Good. If you don't want to remember anything about my presentation, I think you can just remember these 3 words: explore, build, grow. You explore what your user wants, what you want, of course, as well. And then you build a bit on it, you grow your product, and you start all over again. You can apply it on every level. You can explore a feature ID, you can build it, you can grow it on the feature, or you can apply it on the complete product, explore your complete ID, build it, grow it, and so on. So it's an iterative process and put the end user in the center. Good. I was taking the case was there. A lot of companies we work with, make some classical mistakes. So I'll highlight, I think, 4 of them. So you don't have to make them. The first question we get a lot is this feature possible? And as an engineer, I really like that question, and I'm always trying to answer yes, it's possible. We'll make it happen. But I think the right question you should ask yourself: is it possible and is it necessary? Or maybe the other way around: is it necessary and is it possible? Try to make a priorities list. Try to ask your user if that feature you find so amazing, if it's even necessary. The second thing is teams. We already had a lot of teams that were discussing their features before us in our meeting room. And after a very heavy discussion, they reached a conclusion: okay, we're going to build this feature that way. And the end user was never consulted. Teams are very nice to discuss, but don't forget to put the user in your team. Very simple one: come prepared. I think Komet said it as well. There is a lot of things you can do before you come to a company such as us. I'll highlight some tools and some tips I think you should do before you come to a company such as us at the end of the presentation, but please come prepared. You'll be able to deliver way more value and way faster than if you don't come prepared, of course. Finally, it's a very big misconception, I think, or that's the feeling I have, that by iterating, by taking small steps, that you go slower. I think if you iteratively move in the right direction with small steps, you'll be way faster and way better than your competition. Good. I don't know how many time I still have. It's okay. Good. I don't know if is Tom still here.
No, it's gone, but maybe that's better for the case.
Yeah. Good. So we as a team had an application ID. It's called Tom Oro. And it's an application where you can book a meeting or a session with Tom tomorrow. I know it's a genius idea. And I made 10 user stories. And of course, you guys are the users. I'll shortly discuss them. I'll put them on the whiteboard, and then I'll ask you to come forward and put a vote on it. I have some small stickers for that. And you can all put one vote. Okay? So I'll first discuss the green. Could you maybe put them up after I discuss them? Okay, you can already now discuss them like this. So the first one is, does everybody know what a user story is? Yes, no?
Maybe briefly.
Yeah, so it always has the same structure as a persona. So as a person that might want to interact with the application, I want something because. So for example, I'll give an example. As a user, that's you guys, I want to be able to create a wish list so that I can keep track of my most wanted activity. If you always want to do a yoga class with Tom, you can put it on your wish list. So that's one. I'll finish some. Good. As a user, I want to place reviews on the activities to let Tom know if he had a good or a bad day, maybe. And so that others can also get to know what we want. As a user, I want to invite friends to the appointment because going alone is maybe a bit weird, but we can go as a team. As a user, I want to get a refund if Tom cancels my appointment, such that I do not lose my money. As a user, I want to chat with Tom so that I can communicate about my booking if there is some questions. Yeah, then the best birthday gift you can give. As a user, I want to gift an activity to a friend so I can surprise them. But I didn't write them all. Okay. As Tom, I want to let the user pay me for their activity so I can buy my wife flowers.
Sounds like Tom.
Yeah. Yeah, as a user, of course, I want to choose the type of activity. For example, running, wellness, eating, boxing. I can do the activity such that I can do the activity I like. There are 11, 3 more, perfect. So as a user, yeah, I want to see the availabilities of Tom such that I can schedule it in my calendar. As a user, I want to book a meeting with Tom. That's the basic functionality, I think, of the application. We can't forget that one. And as a user, I want to be able to create an account so that I can always, when I book a meeting, don't have to fill in all the information I need. Good. So I'll come forward. I have the dots here. Yes. You have 1 vote. And I hope as a team of users, we'll be able to create an application with, I'll pick out the 3 most voted. And then we as a team also did that exercise and we'll see how we compare to each other. Okay, is it clear for everybody? Yes. Yeah, we have some time left, I think, so you can take your time to read them again.
Yeah, put the sticker on the paper.
Yeah.
Ja, nee. Can we at our audience definitely call it?
Nog iets meer
Ja, en dan als je personeel hebt, ja, dat kan wel zijn. Alles.
Ja, ik ken het wel.
Did everybody vote? Yes, can I have your attention, please? Yes, thank you very much. Good. So I picked out the top 3 that you voted on. So we built an application, Guru. The first one is, of course, the user wants that the app takes into account Tom's availability, so that we want to know when he's available. We want to be able to chat with Tom, and we want to be able to choose an activity so that I can do what I like. The first thing is, why did nobody vote on the making the findings? Your application doesn't even allow you to book a meeting. This was not foreseen, but okay. But it actually quite heavily proves my point that we as a team built this application. I'll read it for you. We want, of course, to book a meeting. We want to be able to place reviews on activities so that you can see what is worth your time. And Tom wants you to be able to pay so that he can buy his wife flowers, of course. That's the one we thought as a team of. And this is the one you chose as users. Can you see how different it is, what the user wants and what we as a team thought? That's the point I wanted to prove. So think about that, use priorities, get some feedback from your audience, and it will most definitely be a bit or completely different from what you had in mind. Okay? Thank you. Where is my... Good. I don't have a lot of slides anymore, but what can you do? What can I do? A lot, in fact. There is a lot out there. So before you come to us, you can create. Just make some basic sketches on paper. That's a very basic thing you can do. Just sketch it out, put some buttons, color it if you want, and explain us, okay, this is the flow I want. If I click this button, I go there, and my user says if they click that button that they have to log out. Just some basic information. If you have that, use these sketches to validate your assumptions. Just tell to your users, this is my sketch, grandma, do you like it? If your grandma is the user you want, of course. And validate, write it down, put some pointers that we have as information. Prioritize. As you can see, I think if you put all 10 of them in an application, it would be nice, but it's not necessary. Just give it a priority Maybe don't let your users decide everything in the priority, or if you'll miss some important features, but you can assign a priority and put it on the roadmap, because you will always have more features than you can do immediately, and then improve on it. If you have the time to iterate the process before you come to us, we might already be able to help you that further. But of course, we're also happy to, just as CoMate, help you during that process of iterating. Good. Finally, some tool tips. I think you get the slides after the session. I really like Figma. It's a very easy tool. You can just draw some applications and you can make it clickable. What does that mean? You can just, without writing a single line of code, create a full application. You can let the users click on the buttons and the application will move as it's a real application. It's free as you can with a UCAN account. This is an application I was researching a bit for this presentation, and this actually lets you convert sketches to a design. So if you're not able to design it yourself, AI can help you to digitalize it. And then those are other programs just like Figma or the other one to help you in the design and prototyping. Landing pages, every great idea needs a landing page. Webflow, HubSpot CMS, very cheap tools, very easy to use. Drag and drop it, and you have a simple website to test your ID, to bring your ID to the world. And then last but not least, there are a lot of no-code applications or low-code applications where you need very little technical skills. Retool is a very interesting one. You can connect it to Google Sheets, which means that you can build a dashboard on Google Sheets. So you put all your data in the Google Sheets, and you can just build a dashboard, a user dashboard with some graphs in it, some visualizations on a very basic Google Sheets. And these three are all slightly more sophisticated than, for example, Webflow. That's also drag and drop. With these three, you can already also build applications. There are companies that build their complete mobile application with programs such as Bubble.io without writing a single line of code. I'm not saying that it will get you to the best product in the world, but it will get you on the market fast, cheap, and close to your user. I think that wraps up my presentation. Yeah, that's my head, and there are my contact details if you want to contact. Thank you very much, and if you have questions, feel free to ask.
Going to say a couple of things more about, some of you are here and you don't have any software or any hardware to develop. So what can you do then? Actually, the flow, as you saw already with hardware, software is similar. It's the same process you need to do. The goal is to make experiments. I think in some of the cases of experiments, like giving a workshop, giving a class, maybe trying it out, the service you want to do with some people, doing it maybe for free, lightweight. So there can be many options if you have more of a service business to already try it out. Maybe do a part of the service you want to do, maybe do it with some support of existing systems where you want to replace it by your own system, but that can be really a great approach to that. So if you need any questions about what can I do with my service, feel free to come to me as well, then I can think with you what is possible. I also want to mention that in the back of the Foundry, we have some sort of hidden secret room, the Makers Lab. Who has been there already? Who knows where it is? YouTube, some know where it is, but not that many. So if you want to see, we have a small space where there are some tables to do some like cardboard prototyping, maybe also some prototyping with some, with Protoplast, which is like Play-Doh, but it can be hard as well. So it's not soft if you touch it once it's cold. We have some like cutters and things like that. If you want to see what is in that room, so you can talk to CoMate, you can talk to VR, but you can also find me in the Makers Lab, which is, if you take before you go out of the main door, you go on the left and you come in the pitch arena room, you go behind the pitch tribune, and then you will find a door. Once you go to the door, you will find another door, and there is the secret space. So we really have some things available. You're free to use it. We know not everyone has enough space on their cot to make it. Maybe you don't have all the tools here in Ghent, so then maybe we can help you with that. I also want to say the slides are already on Ufora. The recording will be somewhere during the week. The recording of the previous session is also on Ufora. Are there any questions? And I think maybe the people online can put them in the chat if you have a question. But are there some questions from here that you want to ask to Guillaume or Mathieu? No? Let me see if there's someone typing. I don't see anything so far. If so, I would say go ahead and find some different spaces. So there, you can go over there if you want some to sit together with some teams. I think you will split up and each take a couple of people with you, probably. And so you can, I would say maybe, yeah, you will find them in the rooms. If you walk around, you will find someone and go and ask the questions. I think for the rest, you can already go and have a drink or find me in the Makers Lab. And then, yeah, that was the end of the session. So I hope it was very interesting. I hope you had a great source of inspiration. And then finally, I just want to thank the people from Coming Time We Are.
Danke.